Hey guys, so I had a question concerning domain of rational functions. Um, so the domain of a function, I think the question was, if we're talking about the domain of a function, what exactly is it and how do we find it? So really quickly, one way I like to explain the domain, your domain is a set of all your x values that have outputs. In other words, the domain, that's the set of all your inputs that have outputs. In other words, another way of thinking of it is that that's all the x values. Your domain consists of all of your x values that you can substitute into this function and successfully have an output without an error message, without something crazy happening, that you will have an output for that input. Now, many times for these types of problems, you will have an infinite amount of numbers that you can substitute into these functions and they be part of your domain. So for me, and this is the question you should ask yourself, what numbers are not part of the domain? What numbers are not part of the domain? So what that means is you want to ask yourself, where or what type of numbers or what number, if I were to substitute it into this function, would give me a problem. It would give me an error. I wouldn't be able to compute that number. So let's look at this f of x function first. And depending on the type of function, you're going to look at it through a different lens. So what I see here with this f of x function is that I have a rational function. All of these in this topic are rational functions, which is fine. So here's the big thing with rational functions. You want to make a note if you're taking notes here. You want to write down that we cannot have 0 in the denominator. Okay, math people are terrible spellers. So here's what I know. I know that if I have a fraction, and just bear with me for a second, and I have 0 in my numerator and some number, I don't know, I'm just going to put 12 in my denominator. I don't care what I have in my denominator. If 0 is in my numerator, that rational expression, that fraction will simplify into 0. But if I were to flip that around and put 0 in my denominator, then my expression would be undefined. We cannot have 0 in our denominator. So I guess what I'm getting at is, with this rational expression, this x in that numerator, it could be anything. I don't care. Any number. It's not going to bother me at all. What we need to pay attention to is this denominator here. I know this denominator cannot be equal to 0. So I know that x squared plus 49 cannot be equal to 0. Now, that also, so from there, you just want to simplify. So let's solve for x. Well, if I were to solve for x, bring this 49 across, then that would tell me that x squared cannot be equal to a negative 49. Well, I'm going to stop there. And this is where we have to think logically just a bit. Think about what happens when you square a number. When I square a number, let's just use a number for example. If I were to square the number 2, 2 squared equals 4. If I were to square negative 2, negative 2 squared equals a positive 4. Is there any way that I can square a real number and the output or the product be a negative number? There's no real number that I can square so that when I square it, my output or my product's going to be negative. So what that tells me is that will never happen. I will never have to worry about there being a number such that when I square it, it's going to be equal to a negative 49. So for f of x, I can substitute any number I want to in there. My domain is the set of all real numbers, because I can substitute any value in there and they will all work. And the way I will write that in interval notation is my domain ranges from negative infinity to positive infinity. And we will work on that. That is just f of x. If you are interested in g of x, watch the next video.